we're going to build upon what we've learned about completing the square and also what we've learned about standard form of quadratics, graphing them, and vertex form of quadratics and graphing them. We're going to put these pieces together. The ultimate goal is that we will be able to take something in standard form and convert it to vertex form using completing the square. Now I'm going to build some background and work through some problems that we've already done, some review problems. So let's graph this using the information we know. First of all, I'm going to graph this using the vertex, which is going to be that the h is opposite of b over 2a. The opposite of b is negative 8 over 2 times a is 2 times 1. So negative 8 over 2 is equal to negative 4. And now I'm going to come up with the k value, the vertex y value, by putting in the negative 4 into this formula. So I'm going to get negative 4 squared plus 8 times negative 4 plus 9. So that's going to be, this is going to be positive 16. Negative 4 times negative 4 is positive 16. Make sure you put a parentheses around it if you put it on the calculator. 16 plus negative 32 is negative 16 plus 9 is going to be negative 7. So my vertex for this one is going to be negative 4, negative 7. Let's put that on our graph, negative 4, negative 7 down here. Now we could look at a table on a graphing calculator, but we've got the tools to do this from the equation. We know that the y-intercept in standard form is that 9. If you put in 0 for x, you get out the 9. So the y-intercept here, you can get very quickly from the graph. And then we can do, and that graph looks like this. If we were to draw it, this half of the graph would be this half of the parabola. And then we can come up with a symmetric point, because if I go to the axis of symmetry, that's negative 4 units, I just go that much further, so double it, and so I'll get out here to negative 8. So this point here, negative 8 comma 9, is going to be my symmetric point. So that's a quick way to come up with the other half of the graph as we go through here, the symmetric point. Okay, so this will go between negative 6 and 7 there. All right, so that's how you graph it using this. Now we want to come up with vertex form here. All right, I'm going to just correct this a little bit here. Make this go a little bit more precisely here. There we go. Okay, to write this in vertex form, we've got the information we need for this because we've got the vertex and we've got the a value. Remember, vertex form is y equals a times x minus h, the quantity squared, plus k. Well, this a here is the same as the a here, which is the number coefficient in front of the quadratic term. So what I've got is y equals, the a here is equal to a 1, so I'm going to have a 1 times x minus the h value here, so minus the negative 4 is plus 4, squared, and then plus the k, which means I'm going to have a minus 7 here. So I can come up with the vertex form, knowing the a and the vertex, we can come up with it. I'm going to show you in a little bit another way to do it using completing the square. Just to review completing the square, let's solve this quadratic equation using completing the square. So to walk through our steps on this, remember the first step is to take and get the constant on the other side. So you want the number, the quadratic and the linear term on one side, the constant on the other. If there's a number in front of the x squared, if the quadratic term has a coefficient, you divide every term by it. Here it's a 1, so I'm all set. So what I'm going to do is I'm going to take half of this 8, which is 4, and I'm going to square it and add it to both sides. So it's going to be plus 16 added to both sides. What you do to one side, you got to do to the other, so make sure you add it to both sides of the equation. This factors into x plus 4, x plus 4. Okay, now we know that because the completing the square, whatever this number is here, half of the 8 is what's going to be with the x here. It's going to end up being x plus 4, that quantity squared. Negative 9 plus 16 is equal to positive 7. Okay, so now I've got that equation. I want to take the square root of both sides. So the square root of both sides, if I look at this, I'm going to get, skipping the absolute value step, because technically this is square root of this side is absolute value of x plus 4. But we're going to instead go straight to the other side, making it a plus or minus the square root of 7. All right, now to get rid of the 4, I subtract 4 from both sides. We put that in the very front so that it doesn't get confused with the plus or minus. And there's my answer for it, negative 4 plus or minus the square root of 7, which is these two zeros. It's actually these two decimal values of where the graph crosses the x-axis. That's where the y value equals 0. All right, so that's a little background and a reminder of what we've done with completing the square. Now we're going to apply that to coming up, doing like we did here, coming up with the vertex form using a general quadratic in standard form. All right, so I'm going to give you the steps. So converting from our standard form into our vertex form is our goal here. So our steps, the first thing you do, first step, is to group the variable terms together. Group the quadratic and linear terms. Okay, the second step then, once you've done that, is you want to factor out the a in front. If there's an a out in front of this, you want to factor it out. All right, now once you've done that, factoring out the a, you want to complete the square. Now this is where it's different because we don't have constants on the other side, so that a is going to come into play. So in completing the square, we've got a little bit of an extra step here. Complete the square. We've got to keep things in order. So the first thing you want to do is, like we did before, half the linear term. And then squared, just like we did before. So just like we're completing the square up here, we took that half of the linear term coefficient there and squared it, added it to both sides, so it's the same process there. And then the second step here, we want to make sure that we multiply by a and add it to both sides, because there's going to be an a factored out here. That a is still hanging around, it's not been divided on both sides. So you want to multiply by a and add to both sides. All right, let's see what that looks like. Let's try a couple examples here. Let's start off with the one we were just doing. Let's use the equation y equals x squared plus 8x plus 9. That's the one that we did earlier. So we already have the vertex form of it. We know what it is. We want to show this process in working it through. So the first thing we want to do is group these two terms together, the quadratic and the linear term. Leave a space here, because we're going to go ahead and complete the square. If there's an a in front of the x squared, you go ahead and factor it out. Here it's a 1, so we don't have to worry about it. Now we're going to go ahead and do this process of taking half of the 8, like we did before, square it, and add it here. So that's going to be half of 8 is 4, squared is 16. If there's an a in front, notice we'd have to multiply by that to see what we added to it, and then we add it to both sides. So I'm going to add it over here, have a plus 16 over on this side as well. All right, so what I have is y plus 16 equals, and here I'm going to have This factors into x plus 4, what the half of the 8 was squared, plus the 9. Now we go ahead and simplify it. We're going to subtract that 16 off over here. So we have x plus 4, the quantity squared. It takes 9 minus 16 and you get the minus 7. Notice that that is the same answer as what we got up here. Y equals x plus 4, the quantity squared, minus 7. This is just completing the square in order to get that answer. Okay, and this is a technique that you'll use later on to work with circles and ellipses and hyperbolas. So you need to learn how to do it with completing the square as well as intuitively. All right, let's do another one. Let's do y equals 2x squared minus 8x and then plus 5. Okay, so the first step we want to do is we want to group the x squared term and the x term, the quadratic and the linear. Next, you want to factor out the 2. I'm leaving a space here because we're going to add something here in just a minute. So I'm going to have x squared minus 4x, leave a space inside the parentheses here. Now, once we've got that a factored out, we want to go ahead and complete the square by doing the half of the negative 4 and squaring it. Half of negative 4 is negative 2. When you square it, you get a positive 4. Now I don't add 4 to this side because really what I've done, and remember what you do to one side of an equation, you got to do to the other side of the equation. And I haven't just added 4, I've added 8 to this side because of that 2 outside of the parentheses. So I need to add 8 over here. That's what this step is. Multiply by a and add to both sides so that 2 times 4 gets added to that other side. All right, so I get y plus 8 equals 2 times, now this will factor into x minus 2, which is the half of the negative 4 plus 5. And now I just have to subtract 8 from both sides. And so I get 2 times x minus 2, the quantity squared, and then minus 3 for my vertex form. So what we've done is we did a little bit of reviewing about what a standard form looked like in vertex form, and then we reviewed over solving a quadratic using completing the square. And then we tied those two together by looking at when we have a standard form, how can we use completing the square to go from the standard form of an equation to the vertex form. This process of using that completing square is going to be a skill that you'll use to modify several equations into this kind of form in the future. So we need to learn how to do it with quadratics as well.